right, so check this out. This was a couple days ago. So, you know, big props to Ashley for spotting this weirdo who just decided that calculus was something that he wanted to check out. So, my man Bernie and his mittens, sensation. So, yeah, he hung out with me while I was teaching a couple days ago, so that was awesome. Thanks, Ash. That was a nice surprise in my Canvas inbox a couple days ago. So you rock. Cool. So let's talk some things today, and I'll actually have a kind of a plan for us moving forward, which I think will be nice. Now I'm going to say a lot of stuff at the end of today, and I will definitely formalize it all on Canvas so we're all on the same page. So you don't have to write all of those things down, the plans of what needs to be done. It'll all be sitting there on Canvas. I'll put like a kind of a plan for the next like 5 days so you know what's going on. But here's what I'm thinking. Number one, I want to ask if there's any kind of lingering questions, confusion, anything about 5.2 stuff with verifying trig identities that we can get out of the way now to make sure we're feeling okay. You don't have to be feeling perfect yet. You don't have to be a 5 out of 5 just yet. But I do want you to be more of like a 4 out of 5, hopefully. Anything from 5.2a, b, or certainly from yesterday from 5.2c that you have any questions about? Okay, good. I'm glad to hear it. Because I'm, yeah, I am definitely done with verifying trig identities. We've done enough. You've got a very decent background on what to look for and kind of how to make things work the way that we want. And so we can move on. Yay, done. 5.3 is solving trig equations. And guess what? We've already done that. Okay. The only thing that's kind of strange about 5.3 stuff is that, you know, they do some of like the quadratics. You can factor. We already looked at that. You know, if it's not a perfect unit circle value, then you just call it arc sine of whatever, or arc tangent. There's stuff in there that we really don't need. Okay, so here's my suggestion to you. If you're super curious, go look it up. Like, go read it. Look at the textbook, go to 5.3, and just kind of flip through, skim through, make sure that the stuff that they're talking about makes sense. Because I'm going to skip it. I'm going to save us some time, I'm going to save us some trouble, and I'm going to save us some monotony of doing stuff we already know how to do by moving on, okay? And I want to go to 5.4, okay? So that's what we're going to do today. And in fact, 5.4 will be the last section that we'll do, okay? 5.5 gets into multiple angle stuff, like sine of 2 theta rather than sine of theta. And we'll cross that bridge when we get to calculus. I don't really need you to worry about the pre-calc version of that. I just care about the calculus version. So I'm only going to focus on 5.4 today. Okay, and so that's what I'm going to teach you. Now, to make your 5.4 lives so much easier, have that trig cheat sheet out. Okay, because you're going to need 2 of those pages. You're going to need the formulas and identities page, and you're also going to probably want the unit circle, the completed unit circle out, because we're going to lean on those values for sure. Okay, because in 5.4, oh, that brand new purple, oh, so nice. It gets into not identities, but formulas. Okay, and so take a look at the second page of that trig cheat sheet, and let me know if you need a fresh link to that. I just leave it up. It's a tab open on my computer forever. The thing about that second page is there's a lot going on there, and we will never, ever, ever get to all of it, and that's okay. We really don't need to. But all of these things are true, okay? But you'll notice that there's a big difference between the top 3 on the left-hand side that are called identities and everything else that are called formulas, okay? Identities we use when we don't really have a theta that we care about actually plugging in. Okay, it's just, I just know it's going to work no matter what, okay? Everything else is for pretty specific angles, usually. Now, could we just leave them as theta or alpha or beta? Sure, but it doesn't really do us much good unless we're doing something with that. Either we're going to actually plug in an angle measure and see what happens, or two angles, right? Because we have alphas and betas, we're plugging both angles. Or we're doing some calculus with it. And we want to just leave it as theta, or leave it as alpha, or leave it as beta, but stuff's going to happen to it when we apply some calculus knowledge. Cool. 5.4 picks on just one of those formulas, one section of formulas, okay? And so what I want to talk with you really quickly about are the ones we're not going to need right now, okay? So look at the left-hand side, right? Identities, 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 yay, done. Those are all the identities we need. Then we get to even and odd, okay? And that just tells us which functions are even and which functions are odd, okay? Even functions are the ones that are symmetric over the y-axis. Odd functions are symmetric through the origin, okay? The ones that hold on to the negatives, those are the odd ones, like sine, tangent, cosecant, and cotangent, those are odd. And the even ones, cosine and secant, because they are perfectly reflected over the y-axis, those are the even ones. Then we got periodic formulas. It just really tells you which functions have which period, right? Sine has that theta plus 2 pi n. Okay, my period is 2 pi. Remember, n is just an integer. If they don't specify n is anything, -5, -3, 12, 100, and a million, but not things like 1/2, not things like e, right? Integers only. Then we got double angle formulas. And you can see, take a look at the double angles. You see how it says sine of 2 theta? And then on the right-hand side, the angle is just theta again. Yeah, now it's 2 sine theta, cosine theta, but there's no 2 in front of my theta anymore. The frequency is not 2 anymore. My frequency is just 1, and that's what I like. My period is just back to 2 pi. And yeah, I need to know sine and cosine to do it, but I can reduce my double angle back to a single angle. Okay, you see it like cosine of 2 theta. All right, there was a frequency of 2 there, and that like squished my whole picture down. I don't like that, right? Now I've got these versions that don't do that. And you can see cosine squared minus sine squared, and then 2 other versions of that you can reorganize using Pythagorean identities, okay? And then below that, we've got degrees to radians. That one we already know. La-di-da-di-da, life is good. Okay, back up to the top of this second page. Again, I know I'm just talking stuff out. You don't have to know these things. If we're not going to do it up here, you don't have to know it. We've got half angle formulas. So we're going from frequencies of 2. Now we've got frequencies of 1/2. Yikes. So now I've got the super stretched out one. Maybe I can get back to a regular period. And that's what those do, okay? Here's what I want to do. The next one, sum and difference. Okay. There's a formula for sine, for cosine, and for tangent, where we can break down the sine of 2 different angles being added together. So imagine this, like if alpha and beta, so remember, theta, alpha, and beta are the 3 most common ways that we write unknown angles, right? So if alpha and beta are 2 different unit circle angles, and they could be in radians or degrees. I'm going to stick with degrees. It's going to make us thinking this through a whole bunch easier because they're equivalent, so it doesn't matter. If alpha and beta are 2 different unit circle angles, and we're going to add them together, or we're going to subtract one from the other. Now, why am I specifying that they have to be different? Well, if I pick 30 and 30 and I add them together, that's 60. And that's already unit circle. I don't need a formula to tell me what the sine of 60 degrees is. I've got the unit circle that can do that, right? 45 and 45, add them together. Oh, that's 90. I don't need the formula to help me find the cosine of 90 degrees, right? I can do that just by doing cosine of 90. They have to be different, okay? And usually, when we add them together, we get a degree measure or a radian measure. I'm going to stick with degrees. We get an angle that I don't know exactly what sine is. I don't know exactly what cosine is because I take numbers like 30 degrees and 45 degrees. All right, 30 is on the unit circle, 45 is on the unit circle, but add them together, that's 75 degrees. Now, of course, it's on the unit circle somewhere, but I have no idea what this, let's say the sine of 75 degrees is, right? It's more than radical 3/2, but it's less than 1, but like, what is it exactly? I don't know, right? Or I could subtract them, like 45 minus 30. Well, 45 is on the unit circle, 30 is on the unit circle, but 15 isn't. Well, I mean, it's somewhere, but I don't know exactly where it is. And so what we've got are these proven formulas that can help us answer those kind of otherwise unanswerable questions, okay? And so here's what those formulas look like. Now, they're right there. I'm just going to write them up here so that I can kind of talk through them. So we've got sine of, okay, alpha and beta, and we could add or subtract them. Okay, so that's why there's a plus or minus in there. We're not going to leave the plus or minus. It's either going to be a sum, 30 plus 45, right? Or it's going to be a difference, okay? And what we've got, which is really nice, is a way to break the alpha and beta apart so that we can use them separately. So I can just do like the 30s and the 45s separate, okay? And so this is what it looks like. And we'll work through a few together so you can see it in action. Okay, here's the way that it breaks down. Make sure I don't actually have all of these memorized, certainly not the tangent one. And we're just going to do sine and cosine. Tangent gets really messy because you've got fractions to begin with, because we've got unit circle stuff. And look at tangent, it's like it's in a fraction itself. So let's just do sine and cosine. Here's the way it works. Okay, if I know alpha and beta, 30 and 45, let's say, we'll actually do that one. Here's how it breaks down. Sine of alpha, like separately. I don't have a plus beta in there, okay? Times the cosine of beta separately, and I'll just kind of evaluate each one of those separately. Now, you see this part of the formula, like there's a plus or minus there again, right? We don't leave it as plus or minus, we pick one. And here's how we know which one to pick. Since this is plus or minus, and this is plus or minus, it's the same symbol and written in the same order. If we're adding two angles here, then I'm going to choose addition. If I'm subtracting two angles here, I'm going to choose subtraction, right? If this is plus, then this is plus. If this is minus, then this is minus. We're not getting two separate answers. I'm just finding the sine of 75 or something, you know? I just want the one y value at that spot. And I can do that by picking the right number. Right, 30 and 45, for example. Okay, plus or minus, and then it goes, what is it, sine of beta next, right? Am I right? Yeah, no, they switch the order. Cosine of alpha times the sine of beta. Okay, alpha and beta broken apart, and then I'll just evaluate each one separately. Okay, there's a cosine one as well. Cosine of alpha plus or minus beta. Again, we're going to pick one. It's going to be plus or it's going to be minus. Okay. This one's a little bit different. Okay. The formula goes cosine of alpha times the cosine of beta. But then look at this symbol, minus or plus. That tells us to switch the sign. That if we were adding in here, we better subtract. That if we were subtracting in here, we better add, right? That's why that sign is flipped upside down. And we're going to do that with sine of alpha times sine of beta. Okay, two guaranteed formulas that are going to work. Okay, as long as I know that alpha and beta are really nice numbers that I can use. Okay. Again, I'm not going to worry about tangent. We don't really need that. It gets a whole lot trickier. If I was doing a full semester long trig class, we definitely would, but we're just kind of touching on the highlights here. Cool. So it's right on that trig sheet. So I just want to practice. I want to show you this in action. Seeing the formulas, yay, but let's actually get down to it. All right, so I'm going to call this one number 1. And I keep talking about the 30 plus 45. Let's do it. Sine of 30 degrees. Put the degree mark because we know it's not radians, plus 45 degrees. Hopefully that's not too far up in the glare. by having the camera up, hopefully it helps a little bit. Okay, here's how this breaks down. I'm going to use the formula. And in my mind, alpha is 30, right? So here's what I got. Like, that's alpha right there, and that's beta, right? Alpha's 35, alpha's 30, beta is 45. And I'm just going to drop those numbers into the formula and see how I can evaluate. So I've got sine of 30 degrees times the cosine of 45 degrees, right? Sine of alpha, cosine of beta. Because it was plus here, I use plus here. That's why it goes plus or minus and plus or minus. Whatever the sign is to start with sine, I use the same one. Okay? And then plus cosine of alpha. Okay, so cosine of 30 times the sine of beta, sine of 45 degrees. I'm going to start working down from here because all of the action is just going to happen on the right side now. So it kind of gave me something to start with. I used the formula to figure out how I can evaluate each one separately. And so that's what I'm going to do. I'm going to do the sine of 30, see what I get. Cosine of 45, see what I get, and so on. And I'm going to just use the unit circle, right? Because cosine is x and sine is y at each of those spots. So scroll to the last page if you want on the trick cheat sheet, or picture the unit circle or have one out. And go to those degree measures and pick the correct coordinate, right? Sine of 30 degrees. Okay, go to 30, pick the y value, 1/2. Moving on. Cosine of 45. Okay, go to 45 degrees, pick the x value. Okay, square root of 2 over 2. Plus. Okay, cosine of 30 degrees. Okay, go to 30 degrees, pick the x value. Okay, radical 3 over 2. Times sine of 45. Radical 2. And now from here, we just simplify. We just try to make this as simple as we can. Now I've got these two fractions being multiplied together, and then separately these two fractions being multiplied together. So let's do that. Let's multiply the first set of fractions together, see what we get. We'll do the same thing with the second ones. And when we multiply fractions, we just go straight across, right? Tops are the tops, bottoms are the bottoms. So 1 times the square root of 2, okay, square root of 2. And then 2 times 2 is 4. Okay, same thing with the second set. And because we've got square roots on top, I can multiply their radicands together, right? Square root of 3 times the square root of 2 is the square root of 3 times 2, which is 6. Numbers inside with numbers inside, numbers outside with numbers outside. 2 times 2 across the bottom there, also 4, yay. And what makes me so happy about what I just wrote down is I'm supposed to be adding these fractions together. And I already have a common denominator, so I don't have to worry about like multiplying top and bottom to make common denominators. I can just write it as one fraction over that 4 and add the numerators together. Now I can't call that the square root of 8. That is not how it works, okay? You can multiply radicands together. You can divide radicands from one another, but you cannot add and subtract them. Okay, there it is. There's sine of 30 plus 45. That is exactly the y value at that spot, whatever that fraction is. Probably something bigger than the 0.866, that radical 3 over 2, but less than 1. Ta-da! That is how we do 5.4. Okay, we are given 2 angles, both from the unit circle, and we go from there. Okay, let's do one with subtraction so you can see that in action. We'll stick with sine though, because I just want to show you what happens with the sine. And let's go, let's see. Could we do, yeah, let's do 120 degrees. This is just something outside the first quadrant. but like minus 45. I like multiples of 45. The thing about making this work, if any of this process is ever necessary, it's got to be a multiple of 30 and a multiple of 45 as your two numbers. Because if they're both multiples of 45, add them together, you still have a multiple of 45. And that's unit circle spot. If they're both multiples of 30, then what you just got is probably a multiple of 60. Or certainly a multiple of 30, and that's already a unit circle. So you need kind of that combination. All right, cool, let's do it. So there's alpha, there's beta. If you'd like to write that down, a little notation for yourself, never a bad idea. And then I just let the formula do all the work. I just have to set it up, right? Sine of alpha, okay, so sine of 120 degrees. If you don't like that I'm not using parentheses, use them. Nothing against it, right? Go for it. Times the cosine of 45, not negative 45. The subtraction between these two affects this sign right there. Okay, if it's plus, it's plus. If it's minus between the two. That's what the plus or minus is for. Minus the cosine of 120 times the sine of 45. Okay, just dropping in alpha and beta right into that formula. And now from here, it's just a little basic unit circle knowledge and then some arithmetic with fractions. Okay. So the trig action really happens right here, right? That's the only real knowledge of trig we need, the formula and the unit circle. Okay, and so I just jump into my unit circle and I pick on the right coordinates from the right spots. Okay, so sine of 120, so I gotta go to 120. Okay, square root of 3 over 2 times cosine 45. Okay, square root of 2 over 2 minus cosine of 120. So go to 120 degrees. The x value at that spot, negative 1/2. I know I got back-to-back negatives here. I'll take care of that in my next step because I know I'm not done. Times the sine of 45, or radical 2 over 2. And just like we did with the last one, once we kind of drop in the 4 unit circle coordinate spots, multiply the first two together, multiply the second two together, and then we'll put them together. So square root of 6, again on top there, because we can multiply radicands together to keep the square root. And then 2 times 2 is 4. And I got 2 negatives next to each other. Great time to call that plus. Why not? And then across the top there, square root of 2. Across the bottom there, square root of 4. Or sorry, regular 4. Regular 4. That's what we say, right? And then, yay, same denominator already. Life is good. And we add the numerators together, but I can't really combine them. Right, that's not the square root of 8. I wish it was. It's not. It doesn't quite work that way with those pesky square roots. So that's what we get. Ta-da! Square root of 6 plus the square root of 2, all over 4. Any questions on these two? Pretty straightforward once you get the hang of it, but you don't have to necessarily have these memorized. You have it's called a trig cheat sheet for a reason. You can use it. So all good? You got it? Cool. Do you notice anything about these two problems?
They have the same answer.
Square root of 2 plus square root of 6, and the square root of 6 plus square root of 2 is the same thing, right? Over 4. And it's not all that uncommon that we're going to get similar and sometimes exactly the same answers, because the only way to really find some of these hidden unit circle spots are like reference angles of 15, reference angles of 75. Right? Those are the only kind of combinations that I can get. So you're going to see a lot of very similar numbers. But why do you think we're getting the exact same answer?
Because it opens up the same amount of degrees.
30 plus 45 is 75. 120 minus 45 is 75. And so what you're going to see is that these questions aren't actually going to start like that. The question is going to be asked, hey, what's the sine of 75 degrees? That's what they're going to ask us to do. They're not going to give us alpha and beta. It's going to be up to us to find a combination that gets you there. And there's a bunch. There are a bunch of different ways to get to 75 degrees, right? Maybe we choose 30 and 45. Maybe we choose 120 minus 45, right? Or maybe we choose another setup or another one. Like there's lots of different combinations of unit circle values that'll get you to that number. But I can't ask you for something like sine of 75 if I don't have the confidence that there's unit circle values that you can either add or subtract to get there. Okay, so keep that in mind. The question really would start like that. Find the exact value of sine of 75. Okay. And then our job is just to find a pair that works. Cool. All right, let's do some cosine ones just so you can see it. And then I will tell you my plan for how we are going to proceed after this. So I'm going to erase the formulas here because we'll do two different ones. We'll do a sum, we'll do a difference for cosine. Cosine of alpha, cosine of beta. But let's start, where'd my phone go? Let's start without the plus and minus. Let's, I just forgot which one I did. I want to make sure that I do the same one. Let's start. Ooh, I like it. Okay. Number 3. Cosine of 165 degrees. All right. I only want to hear from one person, but can anybody figure out a way to rewrite this as the sum of 2 unit circle numbers? Look at your unit circle. Think about multiples of 30s and 45s. That would add to 165.
120 and 45.
There it is. I love it. Let's do it. 120 and 45. Okay, so that's going to have to be your first leap, right? Figuring out what you want alpha and beta to be. Now there's others, okay? And you'll actually have the freedom to try that out yourself next, but I want to do one together with you so you can see the cosine in action, okay? Because the cosine formula is just a little bit different because it goes cosine, cosine, and then sine, sine. So cosine of alpha, so cosine of 120 times the cosine of beta, cosine of 45. But remember the other big difference in cosine. If it was plus to start, then we connect these two terms with a minus, right? The plus or minus became a minus plus. We got to switch the sign. And then sine of alpha, sine of 120, times the sine of beta, sine of 45. Okay, so that kind of initial setup is up to us. What alpha and beta do we want to choose? And you can choose plus, you can choose minus if they don't specify. Sometimes they'll say, you know, find the cosine of 165 by using a sum formula for cosine. Oh, okay, I have to use plus. Or a difference formula. Okay, I have to use minus. All right, cool. But now I just evaluate it and see what I get. So unit circle time, cosine of 120 degrees. I'm trying to picture myself opening up that angle. -1/2, I think. Times the cosine of 45. Okay, those are nice. I like my multiples of 45 because I know those are radical 2/2s. Minus sine of 120, okay, square root of 3/2. times the sine of 45 square root of 2. Okay, so figure out your alpha beta, plug them in, evaluate each of those 4 trig expressions, and then start combining some fractions. Okay, multiply the first 2 fractions together, negative square root of 2 over 4 minus the square root of 6 over 4. Hey, look, I kind of recognize those numbers. It's because there's only so many ways to find these really nice spots. You're going to see lots of square root of 2s, lots of square root of 6s, lots of over 4s, and it's going to be pretty consistent across the board. The only one that gets all funky would be tangent, which is why we're not going to. Cool. Now I can put them together, right? All over 4, sweet. So negative square root of 2 minus the square root of 6 up top is one way to write that. Okay, cosine of 165. Negative square root of 2 minus square root of 6 all over 4. That's one way, okay? The other way to write this is, I think, just a little bit better because my leading coefficient up there is negative. And it's really nice that if my fraction is a negative number, to kind of factor out that negative from that numerator everywhere, like pulling out a negative 1, making my fraction itself negative, pulling out that negative from everywhere so that these signs all switch. Okay, I'm good with either one. I'm very happy to accept this as your final answer, but I do like this one just a little bit more. Okay, tells me my fraction is negative, and now my leading coefficient, this number right here, is positive. Always kind of nice to deal with nice positive. Cool. So there's a cosine one. What I would like you to do is find the cosine of 165 using a different pair. Can you come up with another set of numbers using addition or subtraction that gets you to 165? Okay, don't say it out loud. I want you to try it yourself and make sure you can get to those answers. This should be the same number, just a different alpha and beta combination. Okay, so it could be addition, could be subtraction, whichever one you want. Remember that your sign in between switches. So if you're going to use plus, then this is a minus. If you're going to use minus, then switch it back to plus. Okay, give it a shot. I'll give you a couple minutes. Try that one out. And let me know if you have questions. And once you find a pair that works for you, I would love for you to drop that in the chat. So like, just put like 120 plus 45 or whatever you found. Drop it in the chat so that people don't have to look if they're not ready yet to see. But if you found a pair that works, I would love to hear from you what pair you found that is different than 120 and 45. And I'll write some down. There's a bunch. Nice. Awesome. There you go. Ooh, Ashley. Nice. Nobody did that one during second period, Ash. That was the unique one there. On fire today. Bernie to start class. 300 minus 135. Shit, killing it. Loving it. Nate, your camera's off and I can't see it. It makes me sad. But it's okay. Just be simple. Good. So take a minute, finish that up. Make sure you feel pretty good about getting yourself to that last answer. And then I will tell you some things about what I'm thinking moving forward. When you're done, just look up at your camera so I know that you are done. If you are still working, all good. Cool. So hopefully you have started to find your way towards one of these four great options. And you found that you got to here, okay? And order doesn't matter as long as your signs go with it. So like if you ended up with negative radical 6 minus radical 2 over 4, great, right? Or you factor out the negative, okay, square root of 6 plus the square root of 2 all over 4. Addition and subtraction, as long as you hang on to the signs as the terms move around, are commuters. So you are good there. You'll see that it's the same decimal either way. Cool. So that's 5.4, sum and difference formulas. And that's all I really need us to feel comfortable with is kind of working, like number 4 was your test. Could you, given some spot, could you find a pair of numbers that work? Can you evaluate them using your unit circle? Can you multiply fractions properly? Can you add and subtract? Okay, cool. 5.4, done. Okay, 5.5 is multiple angles. That's the sine of 2 theta, the cosine of 2 theta, the tangent of 2 theta one that I'm talking about. We're not going to do that. We're good. I will save that for calculus when the time comes, which means we are done with chapter 5. Okay, and so here is what I'm thinking, and like I said, I'm going to, so this, we just have 5 minutes, so you're done with your math stuff. I'm just going to give you kind of a breakdown of how I want to proceed from here. And I will put this all together on Canvas. I'll make an announcement later today that will put all this in writing, so you don't have to worry about it. But number 1, you do not have to submit to any of this stuff today, okay? You don't have to do that. I do want to make sure that I go back and get all that stuff graded from 5.2 and even the review leading up to the test. Like I said yesterday, the test grades are in. If you have questions about your test, you want to talk through it, I'm happy to do that outside of class time. Just send me a message and we'll figure something out. We can set up a Google Meet or we can just kind of chat back and forth. I'm happy either way. So that's that. When it comes to chapter 5, here's what I'm going to do, okay? Tonight-ish, probably, I am going to write a chapter 5 quiz. We really only have 2 main sections, 5.2 and now 5.4, but there's only so much that I can ask you without being super repetitive. That I am going to write tonight, probably send out as early as I can, and I'm going to consider it a take-home quiz. Okay, you don't have to log onto a Google Meet, you don't have to do it all at the same time. You will have until Sunday before midnight to get it done. And here's the best part about that quiz. It is optional. Okay, you guys have been working your butts off for me these 3 weeks. Okay, you really have. And I want to reward you with that. Okay, and so here's the reward. You can either take the quiz if you want or not. Okay, but if you decide to take it, you've earned that grade. That grade's going in. So you can't say, oh, I'm going to take the quiz and then back out because you don't do as well as you would have liked. Okay, if you're going to go for it, you're going to go for it. And it's just going to be verifying trig identities and some sum and difference of sine and cosine. Okay, but because it's take home, feel free to use your notes. Okay, I do want you to take it on your own, though. Don't ask other people for help. Ask me. Okay, if you have questions, I'm happy to answer them. Okay, I want you to do well. If you're going to take it, I want you to do well. Okay, now you may say to yourself, oh, I did really well on this first test. I don't want to ruin my grade, even though I still might do well. You know, I got a really good grade this first time around. I don't want to ruin that by getting a grade that's lower. It's a very valid concern. Okay, but realize that calculus is coming, and you might not do as well on our, let's say, our chapter 1 test in calculus. And so I'm just going to pick these numbers out of my brain, but like, let's say you got a 97 on this first test, and oh no, I got a 92 on my chapter 5 quiz. My grade just went down. Well, if you get a 75 on your first chapter 1 test, you now have 2 grades to average into that instead of just 1. Okay, so you get to make that decision. You can mull that over. I'm going to design a quiz that takes like a half hour, 45 minutes, something like that. Depending on how comfortable you are with trig identities, maybe an hour, something like that. But you can do it at your leisure. You can do it whenever you want. You can break it up over time. It's going to be a take-home thing where you just handwrite some stuff. You'll take a picture and you'll put it up on Canvas. Okay, but please do it yourself. Okay, I want to see where you're at so I can help you in case you're struggling. So I will send that out as soon as I can, as soon as I write it. I just had this epiphany this morning. So there's, I hope, some good news, right? Ooh, I get a chance to improve my grade, or I get a chance to average another good grade in so that my calculus stuff doesn't weigh me down as much in case calculus is trickier for you. Haven't done it yet. And speaking of calculus, calculus starts Monday. Okay, not tomorrow, not Friday, Monday. Okay, welcome to your potentially 4-day math weekend. Okay, I am not going to make you do anything tomorrow or Friday or Saturday or Sunday besides take that optional quiz if you're interested. Okay, you won't have any homework. You won't have a review. Okay, the only thing you'll have to do tomorrow is log on to this Google Meet so I can take attendance. The only thing you'll have to do on Friday is fill out the attendance form so I can take attendance. Okay, so for tomorrow, just pop in, say hi, hang out for a minute, and then if you're good, say goodbye and leave. If you have questions about stuff, then tomorrow's a great time to do that. Okay, I'll be here, right? Or I'll be at home, who knows? I might take a home day. But I'm happy to help you if you have questions. But otherwise, it's just an attendance day because you guys deserve it. I've been keeping you, and it's been a lot. So I thank you for all of your hard work. Here's my thank you, okay? So that's that, okay? But in terms of getting ready for calculus, you're gonna have to come pick up some copies of stuff, okay? Which I will have ready for you probably by tomorrow morning. Not today, come by tomorrow or Friday. Across from the security kiosk, across from Leonard and Deb, there are tables that are set up for teachers to put stuff out on. I am going to have a calculus spot where I will make copies of at least our first couple weeks probably, as much as I think we'll need. And then we can always supplement that after that. Now I might do the whole first unit. I don't know, I have to kind of go back through. They're relatively large, but I might just do the whole first unit all in one shot. Okay, so I'm gonna put all this together, but the things you have to know. Number one, come pick up some stuff starting tomorrow for calculus. I will make sure it's easily findable, okay? Number two, you will get a chapter 5 quiz sent to you. Choose to do it or not. You have until Sunday night to do that, okay? But if you are going to submit it, I am going to grade it, Okay, now you could do it and say, man, I really don't know what I'm doing. You can ask for help, great, or you can say, I'm not going to submit it, and that's cool too. Okay. Other than that, I will see you tomorrow for attendance purposes. I will hear from you on Friday for attendance purposes, and I will then see you Monday for calculus. Go to homeroom. Don't forget you got homeroom right now. Thanks, everybody. See ya.
Thanks, Rosie.
Bye.
Thank you.
You're welcome.